In this lecture, we will learn about classification and how to implement this type of machine learning algorithm in Python. Classification, put simply, is when the computer is able to use machine learning to distinguish between different objects. For example, we are going to write a program that has pictures of apples and pictures of oranges, and it will be up to the computer to figure out which is which. Binary classification is where we have two classes of data, and the program sorts the instances into one of the two categories. For example, a binary classification task could identify if a Facebook post is positive or negative by analyzing the words and the emojis used in the post. Multi-class classification is similar to binary classification, where the data is categorized by the program. Whereas binary classification works with two classes of data, multi-class classification works with more than two classes of data. One example of a program using multi-class classification is determining what type of animal is depicted by an image. Since there are many types of animals like tigers, bears, lions, etc., this would be considered a multi-class classification task for a machine learning program. To keep it simple, our program will be binary classification, since there will be only two choices, apples and oranges. The first step is to download the folder attached to this lecture as a course resource, and click and drag it into the directory containing our Python file. This folder has the pictures of apples and oranges that will be used. Then we need to open up the command prompt or terminal on our computer and cd into the directory where our Python file is. After that, we will execute a pip command, pip install scikit-image. When we hit enter, this module will begin installing on our machine. Once that is complete, we are ready to jump into PyCharm and start writing some Python code. Up at the top of the program, we are going to have several import statements. We will import matplotlib.pyplot as PLT. We will import numpy as NP, we will import OS, and we will import joblib. Then from skimage.io, we will import imread. From skimage.transform, we will import resize. From collections, we will import counter. And from sklearn.model-selection, we will import train-test-split. Python needs the RGB data in NumPy arrays in order to handle the computer vision aspect of the program. So we will create a resizeAll function that will be responsible for loading the images from the file path, resizing them, adding labels and metadata to them, and then writing the dictionary to a pickle file using the joblib module. We will use Python's def keyword and name our function resizeAll, and it will take in the parameters source, pickle name, include, width with a default value of 150, and height with a default value of none. Inside of this function, we will create a variable named height, which we will set equal to height if it is not none, else we will set it to the width passed into the function. Note the example here of Python's ternary operator. Instead of an if-else statement, we can set this variable's value based on a condition, all in one line. Then we will create a variable named data, which we will set equal to a new dictionary by using the dict function. Next, we will add the key description to our data dictionary with the value resized, then the width and height fruit images in RGB. This is just data that will tell us that an image was resized. After that, we will add keys for label, file name, and data, but we will assign these to a value of an empty list for now. Then we will have a variable named pickle name that we set equal to a string with the file name. For each subdirectory in the source directory, we will check if the subdirectory is in the include. If so, we will print out the subdirectory to the console. Then we will have a variable named current path that will be set to the path from the source folder to the subdirectory, joined using the OS module's path.join function. For each file in the directory at this path, we will check if the file extension is JPEG or PNG. If so, we will create a variable named im that will hold the image. We will set it to a call to the imread function with the current path joined to the file name, to read in that file. Then we will set im equal to a call to our resize function with im passed in as the first argument, and a tuple holding the variables width and height as the second argument. Next, we will set the label equal to the subdirectory sliced with :-4 passed into the square brackets. Then we will set the file name to file. Finally, we will set data equal to im, the image data that we read in, and then resized. After that, we will dump the data into the pickle file that we created. Outside of our function, we will create a variable named dataPath. It will be fruits/images. Inside of the images folder are the apples and oranges folders that we will reference in a moment. Then we will set os.listdir to the data path that we just set so that the program knows this is where to look for the images that it will use in the program. Next, we will create a variable named baseName that we set equal to the string value fruits. After that, we will have a variable named width, which we set equal to 80. Next, we will have a variable named include that we will set equal to a set with the string values apples and oranges, the names of the folders inside of our images folder. Next, we will make a call to our resizeAll function and pass in a source of data path, and pickle name of base name, a width of width, and an include of include. Then we will have a variable named data and set it equal to joblib.load with the name of the pickle file passed in, so that the file gets loaded. We will print out the number of samples which we can obtain by checking the length of the data. We will print out the keys, which we can obtain by checking data.keys. After that, we will print out the description, image shape, and the labels for the data. In this case, our labels are apples and oranges. Next, we will call the counter function and pass data at the key label. After that, we will set labels to a call to np.unique and pass in data at the key label. This will give us the unique label values. Next, we will create a variable named figure and set it equal to a new figure. After that, we will create a variable named ax and set it equal to figure.addAxes with a list with the values 0, 0, 1, and 1 passed in. Then we will call figure.setSizeInches and pass in 15 as the first argument and 4 as the second argument. Then we will have a variable named x that we set equal to np.array and pass in data at data. After that, we will create a variable named y set equal to np.array and pass in data at label. Then we need to create the variables xtrain, xtest, ytrain, and ytest and set them to train test split with x passed in as the first argument, y passed in as the second argument, a test size of 0.4 passed in as the third argument, shuffle equals true passed in as the fourth argument, and random state equals 42 passed in as the fifth argument. Now we need a function responsible for drawing the bars for our graph. We will create a function named plotBar and it will take in 3 parameters, y, loc with a default value of left, and relative with a default value of true. Inside of this function we will have a width variable that we will set equal to 0.2. Then we will use the ternary operator to set the value of n to negative 0.5 if loc is left, else we will set it equal to 0.5. Next, we will set unique and counts equal to np.unique with y passed in as the first argument, and return counts equals true passed in as the second argument. Then we will create a variable named sortedIndex and set it equal to np.argsort with unique passed in. After that, we will create a variable named unique and set it equal to unique at the sorted index. If relative is true, we will set counts equal to 100 times counts at the sorted index divided by len(y). Then we will set the y label text to %counts. Else we will set counts equal to counts at the sorted index. Then we will set the y label text to count. Next we will create a variable named xtemp and set it equal to np.arrange and pass in lenUnique. Then we will call plt.bar and pass in xtemp plus n times width as the first argument, counts as the second argument, align equals center as the third argument, alpha equals 0.7 as the fourth argument, and width equals width as the fifth argument. And then we will call plt.xticks and pass in xtemp, unique, and rotation equals 45. Then we will set the x label for our plot to the type of fruit, and the y label to the y label text. Outside of the function, we will set the title of our plot to number of photos. Then we will call plotBar and pass in ytrain with a loc value of left. After that, we will call plotBar and pass in ytest with a loc value of right. Next, we will call plt.legend and pass in a list that has a legend, showing which color represents the training photos and which represent the test photos. Finally, we will show the plot by typing plt.show. When we run the code, notice that we see a bar chart. Let's gain an understanding of how to interpret these results. Inside of the apples folder, there are 6 pictures of apples. Inside of the oranges folder, there are 4 pictures of oranges. For our training data set, you see that a total of 6 images were used. 3 were apples and 3 were oranges. These are in blue. We started with 10 photos. If 6 were used in training, that leaves a total of 4 left. Recall that we had 6 apple photos, but 3 were used in training, so we have 3 in our test. We started with 4 oranges, our training took up 3, so we were left with 1. It looks like the computer correctly identified that there were 3 apples and 1 orange in the test group. Great work. You just wrote a classification program that can correctly identify if an image is an apple or an orange. In the next lecture, we will learn about clustering and how to implement this type of machine learning algorithm in Python.